Hi everyone. So in chapter 2, we have started to talk about challenges surrounding connected and autonomous vehicles. We talked about safety issues of connected and autonomous vehicles. We talked about their privacy issues. We talked about some of the challenges with cybersecurity and security. We also talked about infrastructure challenges. And we have started to talk about some of the challenges in general about safety because one of the main challenges that we have is testing and verification of connected autonomous vehicle. So that's a main challenge that we are facing at this point with connected autonomous vehicles because there is no systematic method or algorithm to test the safety, security, privacy, or being ethical as far as connected autonomous vehicle. So in this chapter, in the rest of this chapter, we will talk about more about testing and verification and what are the environments that we can do testing and verification for connected autonomous vehicles. So the first thing I want to share a story with you, and that's the fact that I used to live in Gainesville, Florida, and I used to work in Lakeland, Florida Polytechnic University for almost like 4 years. And between Gainesville and Lakeland, it was almost 120 miles. So it means I was driving back and forth 240 miles every day, and I was driving it 4 or 5 days a week to go from my place to work and come back. So why I'm mentioning this story? I'm mentioning it because I'm trying to say that I drove a lot during past several years. I did that for 4 years, and on top of that, I used to drive a lot before that. And one of my car, I have like 200,000 miles. The previous car that I had, I put the mileage of 250,000 miles, and the current car that I have, I put almost 120,000 miles on it. So the fact is, I drove a lot, and I want to mention that I feel that I'm kind of like a safe driver because I never had an accident, but who knows what's gonna happen. But I feel I'm a safe driver. So why I'm mentioning that? I'm trying to say that if I had an connected and autonomous vehicles for the time that I was driving, let's say from my home to work, I could use autonomous vehicles and I could do other things. I could, for instance, instead of paying attention to the road, if I had an autonomous vehicle, I could do other things. I could, let's say, have a meeting, schedule a meeting. I could review papers. I could read the stuff, but it was not really possible because we didn't have a safe autonomous vehicle. And still at this point, we are not going to have a safe autonomous vehicle that we can rely on that all the time. During the time that I was driving back and forth between Lakeland and Gainesville, I witnessed a lot of situations that as an experienced driver, I never witnessed those situations before. But as a driver, I try to avoid an accident or I try to be as safe as possible. So you can see in this figure, in this map, you can see that we had I-75 that was highway, and then we had turnpike, and then we had two-lane highway from almost here to Lakeland. So I was driving through all of those highway, turnpike, authority, and also like a two-lane highway. So even though I drove all these, every week or every other week, I witnessed some situations that I didn't know what to do. For instance, sometimes there was heavy rain that I couldn't see anything at all. So based on my experience, I figured out if I, for instance, slow down is going to be safer, or if sometimes some people they stop or they don't move their car, that might be safer or that might not be safer. That depends on the situation really, because sometimes people that they stop their car on the side of the road, that is going to cause some accidents. So and I saw some other situations as well, like I saw animals on the highway. I saw other situations that I didn't know what to do. So I'm a driver and I'm an experienced driver. I had those experiences and I didn't know how to do that. How I can learn from those with some sort of like experience, I can learn those situations. But can we really do the same thing for autonomous vehicles? Can we really let them drive in real world and just learn as they drive on road, which is not safe because if there is an accident, that might be a really like a fatal accident, and it can cause or it can basically cause some sort of like damages to their car, or it can have some more significant uh, uh, results from that accident. So the question that I had and always I have is how we can make sure those vehicles are safe and they are secure. So in previous section of this chapter, we talk about security of connected autonomous vehicles, and I mentioned that uh, for instance, everything that we are doing for safety of connected autonomous vehicles to make sure they're safe when they are under false failures and cyber attacks or physical attacks, we have to check them again and again because now the sensors are not reliable, the system is not reliable, so we have to redo that. So the question is how we should do testing and verification. Is it possible to come up with some sort of solutions or find out if those vehicles are fine? So that is the time that we can think about some sort of like a framework for testing and verification, which is going to be a systematic framework. So here is just one example of testing and verification framework that we can use for testing connected autonomous vehicles. We have some edge cases that we are going to generate those edge cases. It can be using AI-based scenario generation or machine learning-based scenario generation that is going to generate some scenarios. On top of that, we have to add false failures and cyber attacks or attacks, and we have to generate that. We have to also check the language of driving and ethical aspects based on our previous conversation. And we have to also take a look at scenario abstraction from real world crashes. If you remember, we discussed the fact that we still have crashes or accidents, how we can learn from those. So we can come up with some simulation of those accidents and we can replicate those as a scenario and we can test the future connected autonomous vehicle and see if they are safe and secure. So there is a difference between testing and verification, which we will get into that. Testing is the fact that generating scenarios and testing it, and verification is the fact that we have to measure the safety of those vehicles, and based on that, we verify that those vehicles are safe enough. So if we generate all those scenarios that you can see here, the next step for us, that's a center which we are going to generate scenarios. The scenario that we generate, it's going to be either based on edge cases or it's going to be based on, and we are going to add false failures and attacks. And at the same time, we have to take a look at ethical aspects and human in the loop aspect. And we have to implement and also take a look at real world crashes. So under this, we have different testing environments. So the first thing for connected autonomous vehicles, we have to take a look at individual unit testing. That's the first thing we need to do. The individual unit testing, it's been done in companies when they are developing some sort of like sensors, drive-by-wire unit, or actuation units. So that has been done already, but the problem is these individual unit testing are done for situations that those components or individual units, they are not working together. When we are talking about connected autonomous vehicles, even when we are thinking about individual unit testing, we have to change our mindset. Our mindset should think about how I can test, let's say, a camera, the accuracy of a camera or response time of a camera when it's used for a specific functional or automation or automated algorithm. So that individual unit testing is a bit different with the individual unit testing that companies are doing, because companies, they give you a data sheet and they tell you how good is their sensor, or how good is driver-wire actuations, or how good is their decision makings. But the combination of this is different. So for every sensors or every algorithms or every actuations or control unit, we need to do individual unit testing when they are working together in one application. So that's the individual unit testing. In the class, I explained it a bit more with more details, but that's the way that we have to do that. We have to combine them together in order to do the testing of even individual. So after individual unit testing is done, the next thing that we have to do is hardware in the loop testing. So hardware in the loop testing is the fact that one part of the vehicle or one part of the system is actual hardware, which is going to be a bit uh, easier to do because it's going to be in a control environment, and we have only one part in hardware, and then the other part that is going to be more costly or it's not safe to do testing in real world, we can use it or we can do it in simulation, and we can combine this together. The other way of testing is vehicle in the loop testing, that a vehicle is in the loop. So we have an actual vehicle, but the scenarios, they can be in simulation, or the controller can be in simulation, or the sensors, it can be in simulation, or actuation can be in simulation, or only the scenario can be in simulation. So that we call it vehicle in the loop testing. The next one is test track testing, which we are going to take the vehicle with all the components, like a ready to go vehicle, to a test track. We have several test tracks that are control environment, and we can do testing on the vehicle. Like imagine a test track as a parking lot that is a closed track, and we are going to test the specific functionality of the vehicle in that test track. We have right now several test tracks, proofing test tracks in several different states. For instance, we have one in SunTrax, which is in Florida, and we are going to talk about that in a few minutes. The next testing is real world testing, and real world testing is the one that companies, they are doing at this point. But we cannot test all different situations on real world testing. And as I mentioned in my previous slide, sometimes we want to do real world testing. We have a problem with the fact that uh, the probability of coming or finding a new edge case or new scenario is not that often. So some people, they say that it takes several years to complete testing in real world situation, and still on top of on that rate, we still cannot test against all situations that it might happen. For instance, we cannot in real world testing test a situation that a vehicle approaches an intersection and a pedestrian is passing by intersection, and we are going to attack the sensors on in that specific situation. So we can't do that because it's not safe in real world. So now there is another way of looking at testing environments. We can categorize testing environments to two types. One of them, we call it offline testing, and the other one, we call it real-time testing. As far as offline testing, the way or environment that we do the testing, we call it software in the loop. So it means everything is in software, like the vehicle is in software, the plant is in software, the algorithm is the software, sensors are in software. So we have model of everything. We have model of sensor, model of the vehicles, we have model of the algorithms, model of the road, and everything is in software. So that can be, the software in the loop can be in both categories. It can be in offline or it can be in real time. Offline is great because we can do million of tests in a matter of seconds because it's offline and it's a simulation time. So for instance, imagine that you are doing a simulation, and you are going to have a simulation of 10 seconds in a matter of, let's say, half a second. So that is offline testing, which is great, which is fine, but depends really on the fact that how good your model is, how accurate your model is. If you want to find a really accurate model for a vehicle, that's going to take a while compared with finding a really simple model or simple differential equation or transfer function for a vehicle. So those are the limitations with software in the loop uh, in general. And then the other limitation that we have with software in the loop when it's happening in offline testing is the fact that sometimes or most of the time when we design an algorithm, it's not going to be working for the situation of uh, 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 real-time scenario. Because, for instance, your sensor cannot really detect all surrounding environment in the necessary time that you want to do some actuations. So that is some sort of like a limitation that we never noticed because we did it in offline. So in order to solve that, people they go and check the software in the loop in real time as well. So real time as well, it means that it's working with the real world clock. Some people they do real-time testing in computers or PCs, which is not really accurate as well because real-time computers or GPUs or others, they have priority and then their clock usually can move or can change based on their priorities. So you can give, let's say, 1 second. 1 second cannot be exactly 1 second. It can be a second and a second point or 2 or 1 second. So that's a problem when we do software in the loop in real time in PCs or GPUs. But the good news is there are some real-time machines that they can do this kind of like software in the loop in real time, and they are pretty accurate as far as the timing and clocks because everything is done in a situation that the hardware clock is checking the time. For instance, let me find you some sort of like real-time machines that they do this kind of, they are used for this kind of like real-time testing. So for instance, a Speedcode real-time target machine is one of them that is used. So if you see in this browser here, you see that these are real-time target machines that they are dedicated for real-time simulation or real-time uh, testing. So there are others, for instance, there is a DSpace target machine that can do the same thing. There are really a lot of different companies that they make target machines that is based on FPGA and it's based on hardware and their clock is super accurate. So but what's the problem? Now we have software in the loop, which is pretty real time if we use target machines. But the problem is the model that we have or the model that we use for the vehicles are not pretty accurate. So that's why people they go to hardware in the loop for their testing. So hardware in the loop, it's going to be a bit more accurate than software in the loop. Um, because part of the system is in hardware. For instance, hardware in the loop, it can be a controller being in a hardware, or some part of the system, let's say some part of the sensors are in hardware. So in that case, we don't need to have a model for your sensors. So we have the actual sensors, LiDAR, radar, cameras. So that is going to be more accurate, but the other parts, which is more expensive sometimes, or we don't want to make a risk, or it's still under development, it's in software, or it's going to be the model of that. So it's still hardware in the loop is great, but it has some sort of inaccuracy because part of the system still is in model or is in software. So after that, we will jump to real world testing. Real world testing is perfect, is great, is accurate, is real time. But the problem is that we cannot test against all different situations. As I mentioned, I cannot attack a car that is driving with 70 miles per hour on a curve and then see how what's going to happen for that car, for decision making of that car under attack. So we cannot test, or it's not safe to test against all different situations in real world. The other things that we can do, which is going to be combination of all of those, is we call it vehicle in the loop. Vehicle in the loop is the fact that the car is real, the controller is real, sensors are real, but we can combine some sort of simulation scenarios in that vehicle. So for instance, we can feed a fake picture in the sensor, or simulated picture in the sensor camera, and see how that vehicle is going to do, or is going to perform under that situation. So in the next video, I'm going to focus more on hardware in the loop, and I'm going to talk more on hardware in the loop and why hardware in the loop is nice and is good. And then after that, we will talk about vehicle in the loop briefly. But the way we are going to continue this class, we will start with software in the loop at the beginning of the class. And then for software in the loop, we need to do modeling of the vehicle, modeling of the sensors. And then for hardware in the loop, we will just do real-time hardware in the loops uh, testing or development. And then we will do, at the end of the semester, we will do some vehicle in the loop, and we will do real world experiments and testing as well. So I'll stop here, and in next video, I'll discuss hardware in the loop a bit more, and then I'll talk about vehicle in the loop and some test tracks.